Hi everyone. So today we're going to learn about epimers. So what exactly are epimers? So before I jump into this definition, I want to show you. I want to give an example and show you how does an epimer look like, so that if you understand what does an epimer look like, you'll be able to follow up the definition and then you'll understand it better. So let us see the examples. So I've taken one example, that is glucose, and then I'm gonna show you how does okay, so this is glucose. So how do I know that this is glucose? Because I followed the code RLR. That means this is the first carbon which has the aldehyde group, and then the second carbon has an OH to the right side, so I've written right. And then in the third carbon, the OH is in the left side, so I've written L. Again, in the fourth carbon, the OH is in the right side, then I've written R. This is going to remain same, this is going to remain same. So only the things that I am focusing on is these three, R, L, R, right? So now let us see how does an epimer look like. So this is also a glucose, but then I'm gonna do some certain changes, slight changes. So I am going to take this second carbon, and then as you can see, in the second carbon we have an OH group, right? But then I'm gonna take this, I'm gonna rub this OH, and I'm gonna rub this H, and I'm going to put the OH to the left side. I'm going to put the H to the right side. So can you see there is a slight difference in the arrangement of the atoms now? If you see in the glucose, and then this particular molecule, we are able this particular compound, we are able to see that everything is same, like everything, like the chemical formula, the number of atoms, the number of spatial arrangements, the type of spatial arrangement of other atoms are same except for carbon number 2. So I've changed carbon number 2. This is the only difference, and carbon number 2 is a chiral carbon. Why is it a chiral carbon? Because it has 4 bonds, it is arranged in a tetrahedral arrangement, and then all the 4 bonds are like attached to different groups, so one group is this, another group is H, another group is this one, and then the last one is this one. This particular molecule is known as mannose. So I'm going to write it down. This is called mannose. Now let us see another one. So let's take another example. Okay, so as you can see in the other one, this is also a glucose molecule. I've drawn like same to same, I've drawn it everything. Now I'm going to make some changes, certain changes in the 4th carbon. So I'm going to make H over here, and then OH to the 4th carbon. Now this particular molecule is known as galactose. Okay, so now if you see here in this molecule mannose, the only difference is in the structural arrangement of the OH and the H of the second chiral carbon. And then if you see galactose, the only difference is found in the C4 carbon that is also a chiral carbon, and the arrangement and the difference in the arrangement of the OH and H in comparison to the glucose molecule. So now let us go back to the definition and try to understand what exactly like the definition meant. So let's see. So what exactly is an epimer? An epimer is a stereoisomer. That means the chemical formula is going to remain same, but the structural arrangement of the atoms is going to differ. And that also where it is going to differ in the configuration at a single chiral carbon compound. So we were able to understand that in the second carbon, single chiral carbon, that means this is the single chiral carbon and this is the single chiral carbon, which was differing in the configuration. So I hope you are able to understand the definition as well. An epimer is a kind of a molecule that has a same structure, same chemical formula, but differs at only one chiral carbon, single chiral carbon. So I took an example of glucose, and then glucose have like the epimers of glucose are mannose and then galactose as well. Now I've written D-glucose. Can you tell me why is it D-glucose? Because the carbon, the last chiral carbon from the functional group, has an OH present in the right side. Therefore, it is D-glucose. If this OH was present in the left side, then we would call it L-glucose, right? So can I call this mannose as D-mannose as well, because it has an OH group present in the right side as well, right? Can I call it as D-galactose because this OH group is also present in the right side of the last chiral carbon. So I hope you liked this video. If you did, please like, share and subscribe. Thank you so much for watching.